Okay. I should turn that into something because right now it just looks terrible.
It's funny.
There. Now I have space.
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 We
Yeah.
did it.
What
We
was
did it.
that?
We're live.
Okay. So when we're recording Daily Space, I make my fonts bigger and roll back and I fit within space. So the screens, ow,
The
that
green
was my
screen.
headphone in my ear. Um, so the green screen is exactly the size it needs to be. And then I'm just super happy with turning it into a window.
I I think it's so cool. Like I think it's a really clever way to have space without it just being like a completely artificial background. Like I don't like people always used to give me a hard time about the fact that it always looked like I was filming in front of a green screen when I was filming in front of forest, which I guess is a green screen.
It's different,
Different kind of green
different
screen.
kind. Yeah.
But yeah, I don't like just having an artificial background
Right.
at all. I mean, I don't even know how to use a green screen, but I like having like an element that is a green screen, and so having that window, I think, is sort of the perfect compromise.
I'm going to show you something though that I did to Annie and broke her during a telecon once because green screens are so much fun if you can get them working right. One moment.
What's going to happen? Don't forget to say hello, and then I'll say hello back to you while we wait. Oh, that's cool though. You could see the green coming through Pamela's chair. That's awesome. Hello from Toronto, John Meadows. Nice to see more Canadians. And of course, Gordon Dewis in Ontario. I think she's run away. Oh, there you go. I see.
So I have
So you have a green
joined
screen shawl?
meetings where I took the time to make sure that my eyeballs were the only thing visible. And I was literally just like floating eyeballs. And I joined a telecon like that while Annie was giving a report. She just lost her shit.
Yeah. Wait, Hobbies Hobo says hello from South Central Vancouver Island. That's cool. I'm on
That
North. I'm on Central Vancouver. I live halfway up Vancouver Island, and yet they call it the North Island. But it's not the North Island. It's like halfway up. It's the Mid Island. And yet they call the bottom of Vancouver Island the Mid Island. Because that's where most
is
of the people live. And so,
so it's done by population distribution rather than
yeah,
geologic
that's
distribution.
that's exactly it. Yeah. So even though I'm like almost at the halfway point of the island
Hi.
from north to south, they call like the South Island, or sorry, the Mid Island, like in the bottom quarter. It's hilarious.
That
Yeah, it's all right.
that's a
It's all
thing.
right. But it's not going to be the hill that I die on. So it's fine. In fact, the less people that think about where I live, the better, because it's awesome.
That works. That works.
Okay, all right. Well, everyone said hello, so let's say hello to Ben Kalo, Bill Sugden, Blowfield 20K, Carolyn Cherry, Crashbox, Daniel McCool, Dustin King, Dustin Reichwin, Exploited, Francisco Sayenz, Gordon Dewis, Greg Nickel, Guido Bibra, Hobbies Hobo, Ian Farquharan, John Meadows, John Suffel, Johnny J, Linda Sadiq, Lionel L, Nancy Graziano, Paul Disney, Paul Gracie, Rich Wilson, Ruben McCarthy, Thomas Setstrup, Umu, Wayne Johnson, and Zappin Zappin. Hey, everybody. Welcome. Welcome to a
Yes.
completely normal episode of Astronomy Cast.
It is exciting to have a completely normal day.
Well, I'm sure it's not a completely normal day for either of us. It's you arrive 3 minutes before we start recording. Like this is, and okay, I'm not going to judge you because I probably didn't start up the Zoom meeting till about 4 minutes before we were recording. Let's just say that we have narrowed down. I can remember 10 years ago when we just stumbled around trying to figure out how to do this thing, and now literally, I start the Zoom meeting. You show up. You're like, hey, okay, we're live.
Yeah, yeah. It's just amazing how this show and everything else we've been doing and all the people that started in this crazy field the same time as us have advanced. Like this weekend, I was like, wait, Ed Young just got a Pulitzer Prize.
Yeah.
I remember when we were all hanging out in a bar together, just sharing like pointers and tips and
Katie Mack conquering the world.
Yeah.
It's kind of amazing.
She I'm really hoping is going to be the big name for the next generation.
Yeah. I think she kind of already is. So I think she's already probably one of the most prominent science communicators / working astronomers out there.
Yes, but I don't think her name is as well known universally as like Bill Nye or Neil Tyson.
Nobody's will anymore. The days of mass media focusing our attention on individual people is gone. It's going to be, and so when you think about how crowded a field it is.
So I have to admit, like I have this deep seated feeling that she's actually going to make the astronaut corps one day.
Does she want to?
And if she makes the astronaut corps and continues being as amazing a communicator as she is today, she's going to, like Chris Hadfield and Scott Kelly, be a household name, but a scientist. And I think that will make her as big a name as Tyson and Nye.
Right.
And that is a day I deeply look forward to.
Yeah. I didn't know she wanted to be an astronaut. Has she applied?
She's mentioned it a few times.
Oh, okay. Yeah. Anyway, if you don't know who Katie Mack is, check her out. She's the best.
Yeah.
What do we do? Oh, right. We make astronomy casts.
Yes.
I'm ready whenever you're ready.
I am pressing record.
Whoa.
Record.
Okay, fine. I'm ready.
You said you were ready whenever I was ready.
I've also pressed record.
Okay.
I just didn't make a big deal of it. Okay. You ready?
Yep.
Okay. Astronomy Cast, episode 610, Confirming Alien Life. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser, Cain, publisher of Universe Today, and with me, as always, is Dr. Pamela Gay, a senior scientist for the Planetary Science Institute and the director of CosmoQuest. Hey, Pamela, how you doing?
I am doing well. How are you doing?
Good, although it sounds like you're being baked, steam broiled there.
It's steamed.
Yep.
It is, according to my sensors down here in the basement, it is currently 96% humidity and it's 102 degrees outside.
Yeah.
And yeah. We're not used to this here, and this is, as so many people here in the North American continent are experiencing, a unusually hot spring. And stay safe, people. Get fans, check on your neighbors. When I lived in Austin, Texas, it was normal that everyone had cooling stations that they could go to if they needed to and couldn't afford AC. A lot of places aren't designed for that right now. And in these still COVID times, I know people are avoiding crowded situations like air-conditioned shopping malls and movie theaters. So take care of each other.
Yeah, that's interesting.
Yeah, we'll get through this.
We're having another January which is a very cold, wet June, temperatures got low. And so we're experiencing the opposite, although we're coming out the other side of it, and we should hit the mid 80s, says my wife, speaking in American. I don't really know what that means, but it's apparently warm. So so it's gonna be it's gonna finally turn nice, but I'm looking forward to
Yeah,
it.
we are getting your weather late next week when our nighttime temperatures are going to get back into the teens in Celsius, into the 50s
Yeah,
in Fahrenheit, and our daytime temperatures will drop down where they belong in the 80s Fahrenheit,
right.
high 20s, low 30s Celsius. And I'm looking forward to that. And I suspect my garden is as well.
Yeah, yeah. All right. So, are we alone in the universe? It's one of the biggest scientific questions that we can possibly ask. And yet, with rovers on Mars, missions planned to visit Europa and Ganymede, powerful telescopes able to detect the atmospheres of exoplanets, we're closer than ever to finding out the answer. And we'll talk about it in a second, but first, let's have a break.
And I'm going to drink my soda.
And we're back. All right.
No, we're not. I was drinking my soda. Try again.
And we're back. I got to admit, this topic, it's interesting. If there's one part of my thinking that I feel has become really nice and nuanced, delving into shades of gray over the decades as my beard has turned shades of gray, I've really come to like a deep understanding of how difficult it's going to be for us to actually find life out there in the universe. Obviously, if there's a big fish skeleton on the, or even just like a bunny hopping around the rover on Mars, then done, life confirmed, let's move on. But it's going to be tricky out there. How difficult is it going to be for us to find life in the universe?
I I honestly feel like this is a two-part question where question one is how hard is it to make the needed detections? And part two is how hard is it to convince ourselves that what we're seeing
Mm-hmm.
is the result of life and not of some other crazy thing that's going on out there?
Okay, well, I think that's great. Let's break this into two pieces then. First, when we think about all of the vast array of scientific instruments that are deployed across the solar system and looking at the universe, what are the techniques that we're trying to use to try to figure out if there's any life anywhere else but Earth?
Well, except with Mars, currently our primary, perhaps our only way of looking is to look at the chemistry. We look at worlds like Titan and say that methane might mean there's either geological processes or life processes that are creating this gas that we know breaks down in the ultraviolet light of the sun. And researchers like Chris McCabe have studied other chemical signatures in the atmosphere and found things don't balance out the way they make you balance equations in high school. And that means there's something else out there throwing the everyday chemistry into something else. And
Right.
that something else doing it could be life or geology as we do not know it, or chemistry as we do not know it.
But it's funny. I mean, you said, apart from Mars, and we'll talk about that in a second. But nobody is looking at Titan right now in any meaningful way, trying to see if there's anything that's pushing Titan out of balance. I mean, when we think about
that's a lack of spacecraft issue.
yes,
Dragonfly will be looking.
yes, exactly, yes, Dragonfly will be looking. Perseverance will be looking. When you think about, like, right now, we haven't even gotten to the point that we can look yet.
Yeah, and this is a frustration that comes from a combination of the people who control the money saying, scientists, you're not allowed to go looking for life. Just stop. Just stop. And when you don't allow people the finances they need to build the instrumentation necessary you don't find the signatures of life. And the other thing is, this is just hard. And until we have surveyed the different space systems, the moons of Saturn, the moons of Jupiter, to identify where are the places there could be life, it's not worth building the expensive equipment necessary to go out and find that life.
Right.
Cassini taught us that Enceladus sprays liquid into space that we can sample. That's something.
Mm-hmm,
The
mm-hmm.
Huygens probe taught us that Titan exists as the triple point of methane. That's something. And Galileo, well, it showed us in so many different ways how all these different worlds are icy. And now Juno is continuing that mission, showing us Ganymede, it has its own subsurface water, just like Pluto does.
And so, I mean, and so again, you're showing that these are worlds and they have atmospheres, but not any kind of sort of deep attempt to try to sense if there is some kind of chemical imbalance that's going on. I mean, when I think about what has actually been attempted, there's like the analysis of methane at Mars.
Mm-hmm.
There was the Viking experiment where they fed soil nutrients and water and tried to see if it produced some kind of chemicals. There was like the discovery of phosphine on Venus, which is a weird chemical in the atmosphere.
Yeah. So I think that
I'm
what
out.
happened,
I'm out of experiments that have been attempted so far.
and I think the Viking mission was an unfortunate life lesson for a lot of scientists, because there were the researchers who looked at the data and said, yes, there is life on Mars. And that was the hill they were willing to die upon,
Right.
and still are to a certain degree. And because of the collective, yeah, we're not going to repeat this experiment that came from NASA, because of the near universal outcry of no, just stop and be quiet, you can't be right. Anyone else is going to think not just twice, but 20 times before they consider potentially risking their career and their reputation as a researcher on looking to replicate those experiments, because if they replicate them and find those same potential sources of life, they don't want to be forced to die on that hill alongside the Viking researchers.
Mm-hmm, mm-hmm. All right. So we're going to shift gears and talk about what is in the works that could give us some of these answers in a second, but it's time for a break. And we're back. All right.
Can we wait for my water pump to stop clicking? Because I know Richard hates when it's, and now there's a dog. We're just going to wait for a moment. I am sorry, everyone.
You're going to you could wait forever.
Well, can you hear the water pump clicking?
Yes.
There, it stopped.
All right.
Okay.
And we're back. So, all right. So we've talked about like just a few just halting attempts so far in where the evidence has not been overwhelming. It has been inconclusive, the worst kind of evidence. So, but let's talk about sort of the next steps then. What are some of the more serious strategies that have been proposed to attempt to find these, I guess, chemicals out of whack, imbalances in a planetary system?
So my favorite is Dragonfly, and this is an exception to my normal never learn anything about a mission before it launches.
Yeah.
And the reason it's an exception is because of all of the work they're doing in Arctic environments. With Dragonfly, they're going to have a lander, and I don't know if you want to call it a drone or a helicopter. They have a robot that can flit around and
A
fly.
rotary craft.
Yeah. and they're going to be landing it near a fairly large crater on Titan. And while Titan itself doesn't get a whole lot of sunlight and is a pretty frozen world, when it gets hit by incoming space rocks, the energy of that impact will melt everything in the vicinity and allow all the kinds of chemical reactions normally tied to warmer places to take place. And right now, there are teams that are exploring a crater on Devon Island in northern Canada, the Houghton crater. And they're trying to figure out, okay, in this icy crater on Earth that was formed in the permafrost, what kinds of melt structures occurred, what kinds of organic chemistry took place in the ice, and where do they need to send Dragonfly to go looking for similar kinds of events on Titan? And they're finding life can exist in this kind of crazy environment. The other thing that I'm looking forward to is Perseverance at some point is going to get out of the helicopter babysitting phase of its exploration.
It's already mostly over. It's moved into its actual science mission now. That helicopter is on its own.
But at some point, it's going to start digging up samples that can be looked at to see what is possibly in the samples. And there are what are called Earth analogs, places on Earth where the environment is not as death as the surface of Mars, but is inhospitable in its own way. And there is a sandstone outcrop in Antarctica, Beacon sandstone outcrop. I don't know why it has that name. Anyways, there's sandstone in Antarctica. And if you go knock out chunks of it and study it correctly under fluorescent light and tearing it apart and looking at the chemistry of it, you find that there's an entire ecosystem in the sandstone. Not just one microbe, but a bunch of life living off of each other's byproducts. And there's sandstone on Mars. And if you can get life living inside the rock, you can get samples of the rock with Perseverance.
Right.
Now, someday bring it back.
Right, which you just answered my next question, which was that Perseverance doesn't have sophisticated enough instruments on board to detect that complex web of biological interactions. It has some tools, but nothing that sensitive. So we need to bring those samples home, and that's like forever, like 2030s before we get some of those samples home. But fine, we're moving forward. So you're going to be able to take a direct sample, look through it, and actually hopefully see these kinds of really complicated, sophisticated biological webs going on inside. That would be amazing. What else do you think is going to be a way forward?
So there has been talk, and this was actually part of the original Google Lunar X Prize, to develop robots that it's possible to drop into cave systems. Any world that has had volcanoes probably has volcanic tunnels, which we have talked about many times.
Yep, lava tubes.
And once you're able to drop robots into those systems, they can go exploring in places that may be warmer due to geothermal effects that are protected from radiation by the rock around them, that are chemically interesting because they're part of a volcanic system. And to go back to those Earth analogs, here on Earth, we have high altitude caves in volcanic systems that support life. There's some at Fuji in Japan, amazing ice caves. There's the Crystal Caves and Lava Beds National Monument here in the United States. And these systems have stalactites and stalagmites that are made out of water instead of out of limestone. And they have their own biology. Hopefully, we will get to the point that we can sterilize the bejesus out of a probe and tether it down into one of these caves and let it do the exploring and look in these safer places, these potentially warmer places to see, does life find a way?
It's interesting how, like with the field of astrobiology, how much of the discoveries of the extreme places that life is finding a way to live here on Earth is helping to really inform the plans for sending these missions to other worlds. And a lot of those discoveries have been really recent. These discoveries, as you say, of life living within sandstone, of life living within these caves, the life around the hydrothermal vents at the bottoms of the ocean. I mean, we've only learned about these within the last couple of decades. And so it's almost as if we got too far ahead of ourselves in searching for life on other, wondering if there's life on Mars when we haven't even done an acceptable job of figuring out where there's life on Earth. And by finding more life on Earth, it will inform our ability to think about life on other worlds. I want to talk about space telescopes and exoplanets in a second, but it's time for another break. And we're back. So we've talked about searching for life and kind of getting your grubby robot hands on samples, and ideally,
hopefully your clean robot hands.
Yeah, your bacteria-infested robot grippers, but hopefully clean, and bringing samples back so that we can study them here on Earth. But probably I think one of the most exciting ways that we could find life is out there in space with our powerful space telescopes. What's that going to take?
It's going to take two different things, I suspect. One, we have to convince people that life forms regularly. We have already been able to prove, because of all of the crazy places on our own planet, that life keeps finding a way to exist, that a lot of places are habitable that we didn't think were habitable. Now, if we can go and look at those places in our own solar system and find, why, yes, there's life here, there's life there, there's life anywhere that life is capable of being, that will tell us that it's easy for life to form. Now, if we don't find life anywhere else in our solar system, given the fullness of time and exploration, it's going to become significantly harder to convince people of what we find out there among the stars. Now, when we're looking out there, we're looking for things that are chemically out of balance and have chemical signatures that are undeniably related to life.
And that's the tricky part.
Yeah. Now, if you're looking at a civilization, this is super easy. You go looking for all of their pollution. You go looking for the IR excess due to space equipment. There's lots of little giveaways, especially radio signals and things like that. If you have too advanced a civilization, that all goes away when they hopefully stop polluting and filling space with junk. But saying that world out there is starting to have life, this gets more complicated. And folks have done some really good models of how the Earth's atmosphere would have appeared at various stages in the evolution of life.
Yeah, I saw that paper.
And so here we can say early on, you're going to have a methane-rich atmosphere due to all the methanogens. You can say at some point you're going to have a boom in oxygen. And then you start looking at all of the chemicals that are unstable and hard to create. And this is where phosphine was such an amazing potential result at Venus. And right now we're at the point of not knowing whether or not phosphine was actually detected. Phosphine is one of those chemicals that is an easy thing for life to create, but generally doesn't spring into existence on its own in the pressures and temperatures that we see at Venus. Mm-hmm. So we're going to be looking for these chemistries,
Yeah.
these biosignatures.
And I mean, it is, I mentioned sort of my increasingly nuanced view of this whole situation, that back in the day, we just thought, oh, well, if we look at another world and we see the presence of molecular oxygen in the atmosphere of a world, that tells us there's life. Oh, well, actually, there's lots of ways that natural processes can make oxygen. Fine. If we see methane, then there's life there. Oh, well, turns out volcanism can make methane. Okay, fine. If we see ozone, nope, there's ways that natural processes can make ozone, sunlight, ultraviolet radiation. And so you go down this list of chemicals and they get more and more complicated and more obscure, and you start to require combinations of chemicals out of balance with each other. And if you went and talked to an astrobiologist right now and said, okay, fine, like what is the thing that we need to be looking for, they wouldn't be able to tell you. They haven't really agreed upon a set of chemicals that, if seen, give you this smoking gun proof of life. And so, and they probably are still decades away of having this definitive answer. And so once again, I think it comes back to what you mentioned earlier, that looking at Earth and considering the history of Earth and seeing what the Earth looked like holistically tells you what to be looking for out there in the universe as well, not just one chemical.
And one of the things that makes it even harder is, what we want to do is take high resolution spectroscopy of the atmospheres of planets. And what this means is we are able to shine light through a planetary atmosphere and divide that light out into the biggest rainbow possible, and then look at the bright and dark pattern in that rainbow in the highest amount of detail possible, and look for all the individual lines that represent different isotopic ratios, that represent different molecules, different atoms. We know that plants preferentially pick out more of one isotope of carbon than another.
Mm-hmm.
And to get all of this detail, however, you need to have a planet that passes directly in front of its star and isn't completely drowned out by the light of its star. And to get that kind of a situation, you ideally want to have a fairly big planet in front of a fairly small star, but small stars have more complicated atmospheres. So the measurements we want are incredibly difficult. In an ideal world, you have a star that doesn't have any of its own fancy banding, but stars that hot, they're probably not going to have life. I mean, we don't actually know any of these things. That's my gut speaking.
Mm-hmm.
But it's a hard set of measurements to make.
Yeah, yeah. And so it really does. This feels like a theme. It feels like a book or something to me that like the finding how interesting life is here on Earth, and how all of the different nooks and crannies that it's found its way into, all the times that it's found a way, at all the different times in its history. That is the story that needs to be investigated, and we won't be able to recognize the story of life on other worlds until we more deeply understand the story of life here on Earth. And we've barely cracked the cover.
And it's a really long book.
Yeah, it's a really long book. Yeah. So I think take a page from me on this one. Don't be patient. That the answer to this question isn't going to be revealed instantaneously. That it's going to be like this gradual unfolding over decades as we gain more and more evidence to try to move towards what is one of the most important scientific questions we can possibly ask. So it's worth the wait.
And let's just hope they find it while we're still around.
Yeah.
We'll be bringing it to you in our wheelchairs from the old folks' home,
Bit
right
by
here
bit.
on Astronomy Cast.
Yeah. Awesome. All right. Thank you, Pamela.
Thank you.
you have some names for us?
I do. So, as always, we are brought to you by you. It is your contributions through Patreon that allows us to keep our website going, to produce show notes, to produce transcripts, to pay our audio and video editors. There is an entire team that heard Fraser and I because we are not to be trusted. And it is that team that gets this show out the door every week. And allowing us to pay our team is Abraham Cottrell, David Gates, Daniel Lossie, Gabriel Galfin, Shannon Humber, Kimberly Reich, the Air Major, Blixa the Cat, Corrine Dumptruck, Glenn McDavid, Niall Bruce, Tim McCannon, Matthias Hayden, Dean, Nalia, John Oshel, Tim Burgess, Stephen Coffey, Blart Flaherty, Pantar, Benjamin Davies, Janelle Duncan, Dean McDaniel, Kenneth Ryan, The Lonely Sand People, Stephen Shewater, Andrew Stevenson, Don Mandis, Jen Grunwald, Rachel Fry, Antisaur, Lou Zealand, Paul Disney, Chris Schaefer, Cooper, Karthik Venkatraman, Gregory Singleton, Philip Walker, Elad Avron, Nate Dietweiler, David, Matt Rucker, Matt Von Coy, Eileen M. Price, and Vanning. Thank you all.
Thanks, everyone, and we'll see you next week.
Bye.
And they stopped and they saved.
It is true.
And they even uploaded.
And I'm going to put it in the Astronomy Cast directory and not in the Daily Space directory.
Too many Too many directories.
Yeah. Yeah, this is one of those. So we are in our prime or our middle ages, depending on who you talk to, which basically means that I at least am at the point in my life where I'm like, I need to think about someday I won't be able to go up all the stairs in this house. And
yeah, it's possible that that's a design requirement in our new house that we're building is no stairs because we expect to grow old there. Yeah.
And so I find myself looking at different missions now, Dragonfly being one of them, and going, it needs to hurry up because I want to know the answers. And so I now worry that some of the science I most want to see happen isn't going to happen fast enough. And this is a new level of frustration. And I look back at all the Voyager people and the Apollo people, and I now understand why they refuse to retire.
Sometimes we have to plant a tree that we'll never enjoy the shade from.
It's true. It's true.
Yep. And
that's still not going to make scientists retire.
Sure. But, I mean, if you're enjoying your work, why should you retire?
Exactly. And sometimes you just want to see that answer.
Yeah. So, but I think that, again, we've been doing this job. We've been doing the podcast for whatever, 15 years. We've both been space science communicators for 20 years.
Yeah.
And when we started, Galileo was at Jupiter. Cassini hadn't launched yet. The International Space Station had only launched one module. Et cetera.
Yeah.
And now here we are, and now Cassini's wrapped up, Galileo's wrapped up, and other missions that were beyond our imaginings are either in flight or so on. So it's this continuum, and we all get to dip into the river of science in our own brief moment along this giant journey, but it takes hundreds of years.
Yeah. This is
Einstein didn't get to see this stuff.
No, science is done by generations, not by individuals.
Yeah. So, but yeah, no, I it's pretty funny because we are, as we're designing what our house is going to look like, we're like, no stairs, like it's just all in one level. No, it's small because it's just me and Carla now. We don't need to have room for the kids. So it is funny as you move through these stages of life and think about these things. And I know what you mean. Like, you're just like,
Yeah.
some of these missions that are even farther, like the Big Bang Observatory, which will be the follow-on to the LISA instrument, that
Hmm.
probably won't fly till 2040. LUVOIR, mid
Yeah.
2030, late 2030s.
Yeah. And
Yeah.
and what really gets me is how the story is changing as we report it. How, like, I gave a talk the other day, and I realized that had I given the same talk early in my career, even I would have thought I was a crazy person. Because I was like, there was water here, there's water
Mm.
there could be life in all these places because hydrothermal vents, and it's just been a wild ride. And every day it seems like the universe is finding it. Lewis Carroll's quote, sometimes I believe six impossible things before breakfast.
Yeah, yeah,
It's how it feels reading the press releases in the morning.
yeah. Hal McKinney asks, if humanity's fossil fuels burning stopped 100%, would the Earth start cooling down?
Not initially, because you would need generations of plants to pull the current gases out of the air. Um, if we stopped everything right now, temperatures would continue to rise
Yeah,
until
for a few
mitigating
decades.
factors would have a chance to take effect. This is what's utterly terrifying, is we are continuing still to make the process worse.
Yeah, so it's not just enough to go to net zero carbon now. Now
Yeah.
we have to go to a net negative carbon, where we have to actually pull the stuff out faster than we're
Yeah.
putting it into the atmosphere. And so not just not produce more carbon dioxide. If
Yeah.
if we if we did hit no carbon, then yeah, the plants would bring it down, and the oceans would absorb it and acidify a little more. And but like the glacier loss is baked in, is,
Yeah.
pardon the pun. Some of the temperature and weather extremes is now just locked in, and now it's just a matter of hoping that it doesn't get beyond a couple more degrees by the end of the century. So, I mean, did you see? You must have seen that recent report about how we've doubled the energy budget in the Earth's atmosphere since
Yeah.
2005. I couldn't
And
believe it when I saw that. That's
what
crazy.
one of the things that really gets me is the disjoint between what is deemed a good economy and what is deemed good ecology, because current global economies are based on the notion of year to year growth. And the only way you get year to year growth in an economy is if you grow your population. This is where we're starting to see China saying 3 children now, please.
Hmm.
And nations like France are frustrated to see their shrinking population, and other nations are accepting in more immigrants. But we need to reduce our consumption, and we're seeing many societies around the world. In China, they're not expecting that people will actually start having more kids because they
No,
realized how much more they can provide when you only have one child.
that is the one silver lining in this whole process, is that nobody wants to have kids anymore. And so
Right.
the natural process in every country, I mean, Japan, places like Japan where they don't believe in immigration are are the worst, where their
Or
population
the
is.
best.
Sure. Yeah, no, for sure. You're exactly right. Yeah. They're experiencing the most loss of population, but
Yes.
Europe is experiencing enormous amounts of it as well. And even the US and Canada would be experiencing it, except we do a ton of immigration here in Canada. And so our population is continuing to grow. And I know yours is as well. So
Yeah.
pretty much now, all through Asia, population growth is stalled. In fact, pretty much the only place on Earth now that population is still growing is in Africa. And I would anticipate a couple of decades from now that will stall out and start to decrease
Yeah.
as well. So, I think it's good.
And a lot of places in Africa and South America, what they're seeing is the current population growth is due in part to families that used to have three children expecting one to live now have all three children living.
Right.
And so there's always a population boom that follows increases in health and both child and parental survival of the birthing process.
Yeah.
Um, so we need to change our economy to see growth on a person to person basis instead of on a year to year increase. And unfortunately, given that we're in end stage capitalism with so many mega corporations only see growth when massive societies buy more. So our economy is going to, by our current metrics, falter. And that's something that has so many people fighting to say there isn't climate change,
Right. Yeah.
even when they know there is, because they don't want to deal with the economics of it.
I think if I was to like pick one thing, as an entrepreneur, as a person who's a big fan of business,
Mm-hmm.
I think the thing that I wish was better handled was just externalities. Like, if I ran a business and I just threw all my garbage on, I was right beside your house and I threw all my garbage on your lawn, you
Yeah.
would be upset. And
Yeah.
I'd be like, well, I'm making money. Who
Yeah.
cares? This is the greatest. And you'd be like, yeah, but I'm having to clean up my lawn. And so that's the idea of an externality. And yet we are doing all of these externalities. We're pumping gases into the atmosphere. We're flushing plastics into our oceans. We're
Yeah.
et cetera, et cetera. We are degrading the soil of the earth, et cetera. And I think that if you could get a handle, like if people were willing to bravely get a handle on the externalities that were being generated, then the modern economy would reformulate itself around adapting to what is the most efficient way, also including the effect of those externalities. So,
Yeah.
right, that like even now, like I buy something on Amazon
Oh,
and it
packaging.
comes in a package that is part paper, part plastic, so I can't throw it in the compost. I
Yep.
can't recycle it. It's
Yep.
garbage.
Yep.
Or even like something will be shrink wrapped, and you're like, oh, come on.
Yeah.
So, and yet that if the seller had the choice between the cardboard packaging with the cardboard, the sort of fluffy paper
Yeah.
padding inside, that I could take the whole thing, just throw it in my compost, and they wouldn't have to pay anything,
Yeah.
or they would have to pay $1 to pick up the packaging again. They would go that route, and yet they're not forced to do it. We are apparently going to be having a ban on single-use plastics in Canada within the next couple of years.
And I forget which nation it was, but I was reading an article the other day. I think it was in Wired, but I could be wrong. That there is a place where they're going to, instead of passing the cost of recycling and garbage onto the consumer, it's going to be passed on to the
Yeah.
companies that are generating all that stuff.
Yeah, and then of course, obviously, the companies are going to have to pass that along to the consumer again, but then they're going to have to, they're going to,
They will rethink the
they'll
costs
rethink
of
everything. Yeah,
everything.
exactly. Yeah. And I think that's the way that you get to have capitalism live side by side with ecology and humanity
Yeah.
and all this. And I think that the trick is agreeing on the externalities and considering. I was listening to a podcast and they were talking about second order externalities and even third order externalities.
Mhm.
So when, for example, like Facebook, when you browse through Facebook and it causes a negative, it causes you to feel crappy because of your happy friends and family, and then that causes a rise in, say, depression and
Yeah.
decreases your level of economic output, that there are actually second order and even third order externalities that are coming along with this. And so I think that if we just spent a lot of time teasing out these externalities, and obviously at some point it's going to become arguments, but
Well,
there's some pretty
and
basic
that one
ones.
goes even further because instead of addressing health issues at the root, we are treating them with medications, which means that in order to try and get those people to be more productive, they're getting put on medications that become a biological waste product that is then affecting how fish and all of the things that consume the fish up the food chain
Yeah.
are functioning. Yeah, it's everything we do eventually works its way back to the environment, and the question is it going to be fertilizer or death?
Yes. Yeah. Yep. Yeah. No. I think that's it. And I think when people are really mad at capitalism, I think what they're mad at is unintended consequences and externalities. I think, like, if you could take everyone's argument about why capitalism is bad and speak it in the language of externalities that are being absorbed by in ways that were, not fair.
Yeah, and here you have to see, like, for instance, the fact that Walmart is the only major employer of unskilled workers in some areas. And because they're the only one, they can pay such low wages that people working at Walmart have to be on food stamps. And so, there, one of the externalities of end stage capitalism is due to lack of competition, Walmart can underpay its employees, who then become a drain on the social welfare system.
Mm-hmm. And again, back to the plastic, right? Again, like,
Mm-hmm.
would stuff in Walmart be so cheap if Walmart had to go and pay to have every piece of plastic that was generated, the bags, etc., brought back and sent all the way back up the chain to the manufacturer? So, yeah, I mean, obviously it's not a silver bullet, but I think it's a good place to start.
Yeah.
Is to think about, to properly address and accept the scientific study into these various areas, which, obviously that'll never happen. So anyway, so I normally don't mention this, but so Jerry Lehane is posting like a whole bunch of just random Mars conspiracy stuff in the chat, and like,
Don't.
don't. Yeah, like, when I'm seeing like 10 messages and they're all from you, one after the other, like, we call that marketing. That's advertising. You've got some ideas, you've come to our chat, and you are broadcasting those ideas, I guess because you're hoping that people here are going to be intrigued and believe them. And like, that's stuff that we're not even talking about. So, participate in the conversation as we're having it, or that's happening in the chat. And then, that's like being a bad guest in our chat.
Yeah.
And you got one of your messages deleted, but I see you do this each week. So please don't. Like, just be a member of the conversation in the community. Don't pitch whatever it is you believe that may or may not have anything to do with what we're talking about. Again, that's advertising. That's what we call that. Hey, you were watching this perfectly good show, but I want to tell you about this other thing. Yeah.
Yes.
Yeah.
Yes.
So don't. Sam, what WTF is this? I was expecting space talk. Lol. Yeah.
This is space. The Earth is a planet.
Here's the planet in space. I mean, we were talking about the Earth's energy budget and how we attempt to wrangle in climate change, and it's definitely an issue. We've got like 4 minutes left, but I want to get like another question.
So Arcatufus is asking, regarding the lava tube rover, don't we need to find them first before considering making the rovers? And we found them.
Yeah, we see them from space.
There is actually thought to be lava tube entrances found on a bunch of the outer moons and even Pluto. And I didn't know that till I read an article
Whoa,
yesterday.
whoa, 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 whoa! Stop! Hold the phones. Say that again. They've found
There,
lava tubes,
well, so cryo ice tubes,
cryo ice tubes, cold water lava
cold
tube,
cave
cold cave
entrances,
tubes on Pluto.
they think.
Uh, Citation, please.
Yeah, it's a letter in Nature Astronomy that was posted earlier this week. Let me,
That's incredible. I have not even heard about that.
yeah, I hadn't either. And there are confirmed, they call them surface entry point, surface access points,
Yeah.
SAPs. There are surface access points identified on a whole bunch of different places I didn't know about. And then there are ones that are fairly well studied on the moon and Mars.
Yeah. So there are photographs from orbit of Mars and the moon that show skylights, the collapsed rooftops of
Yeah.
lava tubes.
And so during the Google Lunar X Prize, some of the mission teams, and I unfortunately can't remember which ones, actually as like an add-on project had planned to have little tiny, essentially Lego wheeled devices that they dropped on tethers into these tubes that would be able to take some images from inside. And it's really amazing.
This is incredible. Okay, can you beat boop me the paper after the show?
Yeah.
Because
Yeah, I have a PDF I can send
that's
you.
amazing. I had no idea this was a thing.
Yeah, I didn't either.
Yeah.
It was,
Yes, please. Okay, but anyway, like regular rock ones, lava ones, yeah, we see them on the moon, and we see. Do a Google search for lava tube skylight moon, or
yeah,
lava tube
or
skylight
Mars.
Mars, and you'll get a picture, and it's incredible. Like you can see the the landscape, and then the hole, and then you can even see like where sand has fallen into the tube and piled up in a little pyramid inside the tube. It's incredible.
Yeah,
Is beep
it's
boop a technical term? Yes, yes. It means transmit by whatever method you find most convenient from you to me. Yeah. All right. Well, we've reached the end of our hour. Thank you for that. That's amazing. I'm stoked.
yeah, yeah. It's I'm gonna find the link while you chatter.
Wonderful. All right. Thank you, everyone, for joining us this week here on Astronomy Cast. We really appreciate all of you, both on YouTube and on Twitch, as well as the hardworking moderation of our moderators.
Yes.
Especially, of course, to Nancy Graziano, who keeps us organized. We couldn't do this without you. And we will see all of you next week. Thanks,
Goodbye,
everyone.
everyone. Yeah, this was